Rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by ML Khanna sir, and I am Subuh Nadeem, presenting you the videos of this book, some of the selected questions and concepts. So the chapter which we are discussing is chapter number 25, multiplication of vectors. So there are some basic concepts about multiplication of vectors. If we say a vector A is there, so there is a vector A and we are taking dot product with another vector B. So this would be mod of A into mod of B and then cos theta. What is the angle between A and B? That is theta, which is taken over here. So the vector A is this one, vector B is this one, and the angle theta is between these two vectors. So we are taking A dot B as mod of A into mod of B cos theta. Now some of the important results about it we know that if A dot B is equal to 0 and A and B are non-zero vectors, that is their magnitude are not 0, then we can say that theta is equal to 90 degree. If A and B are non-zero vectors, this we have to keep in mind. Next we have another point over here which is about projection. So if we talk about projection of A on B, so there is a vector A and there is a vector B, and we take B over here like this and A vector over here like this, and we talk about the projection of A on B. So I am highlighting it. This is the projection over here. This is the projection of A on B, and the angle between them is theta. So we say that we have A mod cos theta is the projection of A on B. Now what is A mod cos theta? This can be written as A into A dot B by mod of A into mod of B, right? So mod of A will get cancelled and we say that A dot B by mod of B. So this is projection of A on B. Similarly, if we talk about projection of B on A, so if we talk about projection of B on A, what will happen? So we take like this. This is projection of B on A. And in that situation, this would become A dot B by mod of A vector. So this is another point. Now we have another result which says, like if we have A cross B, then we have A mod B mod sine theta n cap vector. So this is a vector quantity. A dot B is a scalar quantity, that is it has only magnitude, no direction, but A cross B has direction n cap. What is n cap? It is perpendicular to A and B, that is the plane of A and B. So if we take A like this and B like this, so this is the plane, so we take A cross B like this, and this is the direction which is coming out of the plane towards you. If we would have taken B cross A, then it would have been inwards, away from you. Now theta is again the angle between A and B. So we have to know that A cross B and B cross A are not same, but minus of B cross A, that is direction is opposite, just opposite. Now if A and B are non-zero vectors, then what we can say that we have sine theta is equal to 0 if A cross B is equal to 0, which means A is parallel to B because the angle between them is 0. So this is A cross B is equal to 0. Next what we have here is, let us talk about components. So if we have a vector and the A vector says that it has component A1 I cap plus A2 j cap plus A3 k cap, and B is a vector which components B1 I cap plus B2 j cap plus B3 k cap, then we take A dot B, which will become A1 B1 plus A2 B2 plus A3 B3. And if we talk about A cross B, what will happen? That will be a determinant with first row as the unit vectors I, J, K, second row as A1, A2, A3, and third row as B1, B2, B3. Right, students? So this will be a vector quantity. When you will expand this determinant by determinant formula, you will get a vector quantity with I component, J component, and K component. Now, another thing which we have to know here is about a scalar triple product. So what is a scalar triple product? If we take A cross B dot C, then that would be, you can take the cross product first, then only the dot product will be taken, or you can take A dot B cross C. Both is same. It is cyclic actually. So this is also represented like this: A, B, C, a scalar triple product. And this will be, if you will write in component, this will be a scalar quantity with first row as elements A1, A2, A3, second row element B1, B2, B3, and third row element C1, C2, C3. So this is how you can write it. Now if you have to know that if A, B, C are coplanar, that is they are lying in a plane, then in that situation, what we will say, that their scalar triple product is equal to 0. That is the volume of the parallelepiped with their adjacent vectors as A, B, C. If we take, so this is A vector, this is B vector, this is C vector. So this is the volume of the parallelepiped A, B, C, and if it is coplanar, that the volume of the parallelepiped will be 0. So we have few questions here to discuss. Prove that the points 2i minus j plus k, I minus 3j minus 5k, 3i minus 4j minus 4k are the vertices of a right angle triangle. Find the other two angles. So this is a vector we have, and this vector is 2i minus j plus k. This is I minus 3j minus 5k, and this is 3i minus 4j minus k. And this is these are the vertices of a right angle triangle. So we have a right angle triangle like this, and we have 2i minus j plus k as one of its vertex. This is A, right? Then another position vector of B is given, I minus 3j minus 5k, right? And another position vector is given, 3i minus 4j minus 4k. Now what we have is AB vector. AB vector is B position vector minus A position vector. So what we say, that it is minus I cap, as we are subtracting from B A position vector, OB minus OA, minus 3j cap plus j cap minus 2j cap, and minus 5k cap minus k cap, that is minus 6k cap. BC vector is position vector C minus position vector B. So that will be 2i cap, and then we have minus j cap, and then we have plus k cap, and then we have CA vector. So position vector A minus C. So minus I cap, then plus 3j cap, and then plus we have A minus C, right? So plus 5k cap. So what, this is what we are having. From here, can we find mod of AB? Of course, we can find mod of AB. What will be that? So I am writing mod of AB here. Mod of AB would be 1 plus 4 plus 36. That will be root over 41. Mod of BC. What will be mod of BC? 4 plus 1 plus 1. That is root over 6. And here again, if we calculate 25 plus 9 plus 1, that is mod of CA. That is root over 35. So right angle triangle. So that means AB square here is equal to BC square here, right, plus CA square. That is, it is satisfying Pythagoras theorem. By the converse of Pythagoras theorem, we can say that this is a right angle triangle. At which point? At a point C here. So this is right angle at C. So if we write a correct diagram, that would be like this. At C, this is right angle, and this is B, and this is A. So this is right angle at C. Now if you are asked to find the angle between this vector AC and AB, what will you do? You will find cos theta. So what if we find cos theta here, that is cos theta is equal to AC vector dot AB vector by mod of AC into mod of AB. So AC vector dot AB vector. AB vector is this one, AC vector is this one. If you take a mod of these two, you will get 1, and then you will get minus 6, and then you will get minus 30, right? Mod of this you take by magnitude. Magnitude of AB is root over 41 and magnitude of AC is root over 35. So you write like this. This would become 30 and 6, 36, and 1, 35, right? 35 by root 35 is root 35. So this will become root over 35 by 41. So the theta angle is this one, or you say AC and AB. So AC and AB, this angle. So this theta angle is cos inverse of root over 35 by root over 41. Similarly, you can find the angle between AC and BC, alpha angle, or you can just say 90 degree minus theta is alpha. So not AC but B angle. So this is 90 degree minus theta. So you can find the another angle. This is not the right figure, this is the right figure. This is what we have initially drawn because we didn't know the actual right angle. After knowing the actual right angle, this is the final figure. So you know here B is to be found and A is to be found. A is theta and B is 90 degree minus theta, right? Now we have another question. Prove that the points this one, this one, this one are the vertices of a right angle triangle. Find also the other two angles. So this is the same question as we have just seen. Let us come to the next question. If two medians of a triangle are equal, the triangle is isosceles. So if we have two medians of a triangle, so we have a triangle like this, and let us take these as the axis, x axis, y axis, as we can take in a plane, xy plane. This is the origin, this is the position vector A, and this is the position vector B. Now the two medians could be taken like this. Suppose I am taking a median from this point to here and from this point to here. So this is this point P, this point is Q. So P position vector is actually B by 2 and Q position vector is actually A by 2. Now if two medians of a triangle are equal, then the triangle is isosceles. Now these two are said to be equal. That is this length, AP length. So what is AP length? A minus B by 2, and this length is equal to BQ length. So what is BQ? As you can see, B minus A by 2. So these two are equal, right students? So the two medians are of equal length. Now it is being further asked that tell that the triangle is isosceles triangle. So it seems from symmetry that we can prove that A is equal to B. The magnitude of A is equal to magnitude of B. Let us see. So first we will square both the sides and then we'll take its dot product with itself. So this will be mod a square plus mod of b square by 4 minus a dot b, like this. And this would be equal to mod b square plus mod a square by 4 and then minus a dot b here also. So why we are doing like this? Because this is a minus b by 2 dot product with a minus b by 2. Here also b minus a by 2 dot product with b minus a by 2. This is why we are doing it like this. Now after doing it like this, what we can do is, the next step, minus a dot b and minus a dot b will get cancelled. Mod of a square minus mod of a square by 4 will become 3 mod of a square by 4. And here it will be mod of b square minus mod of b square by 4 will be 3 mod of b square by 4. So we can cancel 3 by 4 and we have mod of a square is equal to mod of b square, which can be written as mod of a is equal to mod of b. So as we wanted that this length mod of a is equal to this length mod of b. We can now move on to the next question, students. So the next question says a, b, c, d are 4 distinct vectors satisfying the conditions a cross b is equal to c cross d and a cross c is equal to b cross b. Then prove that a dot b plus c dot d is not equal to a dot c dot b dot d. So this is a dot product right here, and we have this multiplied with this dot product. So this is a multiplication and this is the dot product. You can say that these are the vectors, and you are getting a scalar here, and there is a multiplication. And here also dot product, and here also dot product of two vectors. Now what is given is a cross b is equal to c cross d and a cross c is equal to b cross d. So what we write here is a cross b is equal to c cross d, and another equation is a cross c is equal to b cross d. So when we subtract them, we get here a cross b minus c is equal to, here we get c minus b cross d. So I'm subtracting 1 minus 2 doing. Now if we write it further, a cross b minus c is equal to, this will become d cross c minus b with a negative sign. So it will become d cross b minus c. As we know that a cross b is minus of b cross a. So this will what will happen here. Now if we take b minus c on one side, so b minus c is equal into a minus d is equal to 0. So this is actually cross product here. So keep in mind when you are multiplying the vectors, whether you are taking a cross product or dot product, it is very important. In the next step, if we say that this line, this vector and this vector is a cross product is 0, then what it means that these are parallel to each other. So b minus c is parallel to a minus d, right? And this is what we have to prove here. So how can we come to this result? Let us see. So we can say that b minus c parallel to a minus d. So b minus c dot product with a minus d is not equal to 0. What it means? That b dot a plus c dot d minus c dot a minus b dot d is not equal to 0. This is what we can say. So further what we can write is a dot b plus c dot d is equal to a dot c plus b dot d is not same. So here there is a small change in the question which is to be needed. Actually it is a dot b plus C dot D not equal to A dot C plus B dot D. So this is a plus sign over here. So this you have to keep in mind. This is a question printing error which you can correct yourself if you will solve it correctly. So let us see the next question. Let the vectors A, B, C and D be such that A cross B cross C cross D is equal to 0. Let P1 and P2 be planes determined by the pairs of vectors A, B and C, D respectively, then the angle between P1 and P2 is. So it is said there is a vector which is determined by a vector A and a vector B. Then another plane is there which is determined by vector C and vector D. And it is said A cross B cross C cross D is equal to 0. So what is A cross B? That is a normal to this plane, and which is C cross D, that is normal to this plane. So we can say that normal to the first plane cross normal to the second plane is actually 0. Now it is said what is the angle between the planes. So if the normal between the normal of the two planes are having cross product 0, what it means that n1 is parallel to n2. These two normal vectors are parallel. Then can we say that the planes are also parallel? So we can say that P1 plane is parallel to P2 plane. So the angle between them is actually 0. So we can say that the planes are also parallel. So let us come to the next question. Is if R is equal to this vector, then R cross I dot R cross J plus XY is equal to. So if we take R cross I, then it would be I, J, K, X, Y, Z and 1, 0, 0. And this would become, after expanding the determinant, Z J cap minus Y K cap. If we talk about another one, R cross J, it would be I, J, K, X, Y, Z, 0, 1, 0 is equal to Z I cap minus X K cap with a minus sign. Z I cap minus X K cap like this. And then we have to take the dot product. So if we take the dot product of these two, so J dot I will be 0 because it is the dot product of two perpendicular vectors. J dot K will be 0 and K dot I will be 0, whereas K dot K will be 1 because cos 0 is equal to 1. So we have minus Y and this is plus X. So minus YX, and then we have plus XY, which will be equal to 0. So we can say that option A is the correct option. So the next question is, prove that the right bisectors of the two sides of a triangle are concurrent. So if we try to do this question, what we have actually is, we have a triangle like this, and this is the x-axis, this is the y-axis. Let us take this point A as having position vector A, this point B as having position vector B, and this is the origin with position vector 0. Now if we take the midpoints, because we have the right bisector, so bisector of this, let us talk about. So the midpoint is P A by 2 and this right bisector. Then we have Q B by 2. And let us suppose they intersect at P. Let they intersect at R, which is R vector, position vector. So can we say that R minus B by 2 dot R minus B by 2 dot B is equal to 0? Yes, we can say, because this is a right bisector perpendicular. Similarly, can we say that R minus A by 2 dot A is equal to 0? Yes, we can say that again, because this is a right bisector perpendicular. So this will become R dot B is equal to mod of B square by 2. And this will become R dot A is equal to mod of A square by 2. Now we have here third condition. Third condition says that we have another perpendicular bisector which is passing through R. So if we take a bisector and we can prove that it is perpendicular to this third line, then it is said that it is also passing through R. So let us take this midpoint as B plus A by 2. So this point is M. So if we talk about PM, RM, this vector. So this vector is B plus A by 2 minus R vector. This is RM vector. Now we have this RM vector perpendicular to AB vector. So RM vector is perpendicular to AB vector. If it is so, this we have to prove actually. So what we do? We take RM vector dot product with AB vector. So we take B plus A by 2 minus R dot product with B minus A. Right? After doing this, what we can say is, let me erase this portion which we have already used. So this result we will use right now on the right side, which is written here. So when we say this, we can say that we have B plus A by 2 dot B minus A by 2, that will give you B mod square by 2, and then we have minus A mod square by 2 minus R dot B minus A. So that will be taken as R, this is minus, so this is actually minus here. So minus R dot B minus A. So R dot B minus R dot A is equal to, now R dot B as we know is B by 2, B square by 2 it was, and this was A square by 2. So R dot B is B square by 2, right? And R dot A is A mod square by 2. So if we see here, then the terms are getting cancelled actually. So mod of B square by 2 minus mod of B square by 2 is getting cancelled, minus A mod square by 2 plus A mod square by 2. This is minus minus plus. So what you get? You get 0, which means that this vector is perpendicular to this vector. That is, RM vector is perpendicular to AB because their dot product is coming out to be 0. The angle between them is 90 degree. Now let us come to the next question. If ABC are three vectors, prove that A plus B, B plus C, C plus A is equal to 2ABC. So the scalar triple product is actually of A plus B, B plus C, C plus A, and here ABC. So, and further we have to prove that A plus B, B plus C, C plus A are coplanar if and only if ABC are coplanar. So first of all, let us first prove this first part, that is A plus B, B plus C, C plus A. And when we take the scalar triple product A plus B dot with B plus C cross with C plus A. Then we have A plus B dot with, now B cross C, that can be written as B cross C, B cross A, that can be written as B cross A, then C cross C, that will be 0, plus C cross A we will have. This is A, B, C. When you take the scalar triple product, what will happen? Here you will get A, B, C. That is the scalar triple product A, B, C. Then we have A, B, A. That is the vector B cross A, that is the normal to this plane, and you're taking with A dot product, that is a vector on this plane. So the angle is 90 degree, which means the value will be 0. Again, A dot C cross a plane where C and A are there, and you're taking the cross product perpendicular to this plane, and you're taking dot product with A, which is in that plane. So again 90 degrees the angle, which is 0. Now B dot B cross C will also be 0, again for the same reason, B here also, and B cross A again will be 0, B here also, and then B C A. So first one was ABC, next is BCA. Now as it is cyclic, that means BCA is same as ABC. So ABC here also, ABC here also. So it is 2 times of ABC. This is how we can prove it. Now we have that if they are coplanar, then in that situation, that A plus B plus C, C plus A will be 0 if and only if ABC scalar triple product is 0, which is true, because ABC scalar triple product and the scalar triple product of these vectors is same. So if this is 0, this will be scalar triple product 0, or is this scalar triple product 0, then this is also 0. So both ways it is true. So we have the next question, the value of A, so that the volume of parallel pipe formed by vectors this becomes minimum is. So what is the volume of the parallel pipe? Volume of the parallel pipe will be, as you know, is a scalar triple product of these 3 vectors, that is 1 A 1 0 1 A 0 1. So you take 1 here, this is 1 minus 0, 1 is there, then we have minus A, and then we have minus A here again, so plus A cube, then we have 1 minus A, and this is actually the volume of the parallel pipe. Now this is minimum, that means dV by dA is equal to 0. So this would mean 3A square minus 1 equal to 0. A is equal to 1 upon root 3. So the value of A is coming out to be 1 upon root 3. So that is all for today's lecture, students. Thank you.